This conference will now be recorded.
Welcome everybody to Satellite Book Club Seminar Series. This is session number 224. My name is Dan Lindsay with NESDIS. Today's presentation is by Bill Line, who is a physical scientist and Imagery Science Team lead for NESDIS STAR. The title of his presentation is Operational Applications of VIIRS Imagery for CONUS Offices. And our facilitator today is Jarrell Torres, Research Associate 3 and JPSS Satellite Liaison from CIRA. As a matter of fact, I can see Bill, if I look to my right, very close by. We're waving at each other, and Jarrell is just down the hall, so we're all very close together. Just a reminder to the audience that this session is being recorded per the OCIO Privacy Act guidelines. Please keep your microphone muted and webcam off throughout the session, and see the pinned message in the chat for more information on that. We're going to be doing a Q&A session after the presentation. I'd like to encourage attendees to post their questions in the chat room, and they'll be fielded through there. If you're logging in through an alias account, please sign in with your full name or specify your full name when asking a question in the chat. We're always looking for future presenters. Please contact the Tower S team if you're interested in presenting. The Satellite Book Club, the training team can help create training materials that may be unavailable. Contact Ross Van Til for information or questions on that. So before we get started, a quick thank you to OCLO, the GEO and LEO programs, and our facilitator today, Jarrell Torres. To introduce Bill, he is a common, or very frequent presenter here. He may have the record actually for the most presentations. I'm not sure on that. Bill is a physical scientist and the Imagery Science Team lead with the NESDIS Center for Satellite Applications and Research in Fort Collins, Colorado. Bill conducts validation, research, and development of satellite imagery-based products and tools, and previously Bill was a forecaster with the National Weather Service in Pueblo, Colorado. So welcome back, Bill. Take it away.
All right, thanks a lot, Dan, for the introduction. Pretty neat. We have the Fort Collins takeover of the book club today. And thank you all for joining, and thanks to the book club for inviting me back. So today I want to share some situations where I believe VIIRS imagery could provide complementary and unique value when used alongside GOES imagery, specifically for CONUS offices. Of course, GOES imagery has the higher temporal resolution and much better latency than VIIRS, especially over the CONUS. However, VIIRS does have very high spatial resolution compared to GOES, as well as some unique spectral characteristics. So how can we take advantage of those slightly, at least, improved characteristics to, again, provide complementary value for GOES data, which we know you're using? We don't want to add anything to your plate that's not necessary. So where can VIIRS provide that added value? And focusing on the CONUS, of course, in Alaska, VIIRS becomes even more important since your GOES data starts to degrade, especially over far northern Alaska, and they have a lot more coverage from VIIRS due to swath overlap. So today, focusing on CONUS applications. I'll skip that. So starting with some VIIRS basics, just really quickly, we all know VIIRS has 22 spectral channels, including the 16 bands at 750 meter resolution and 5 bands at 375 meter resolution. And then there's also the unique day-night band, which essentially provides you with visible imagery at night due to reflectance from lunar illumination. So currently there are 3 JPSS satellites, each with a VIIRS instrument, and essentially what you're getting over a given point, or discounting swath overlap, the image sequence, for example, over the CONUS, you would get an image, then you'd have a 25-minute break, another image, a 25-minute break, another image, and then a 50-minute break, and then that cycle repeats itself. It doesn't really matter what satellite the image is coming from. It's very similar imagery from each satellite. So just know that you could get, during the evening and then again during the day at your location, any location over the CONUS, you're going to get roughly 3 to 6 passes from a VIIRS instrument per again per between about 12 and 3 p.m. and again 3 to 6 more passes 12 to 3 a.m. and those passes again would come in that sequence separated by 25 minutes or 50 minutes. Latency for direct readout data, which is what's available on the CIRA slider, which I'll show, is roughly up to a half an hour, so still considerable latency compared to GOES, but again, can we overcome that latency with the other advantages of VIIRS? So moving on to where we can view VIIRS imagery, you as a forecaster in a WFO in a CONUS office. Of course, first there's AWIPS, and there's really not much VIIRS imagery in AWIPS. And again, this presentation is focusing on imagery and not derived products. The main product available to you in the CONUS is the day-night band near constant contrast product. Again, this is providing you with visible imagery at night. This product comes not direct readout, so it has a higher latency, up to sometimes 1.5 hours, which in my opinion makes it almost useless. So obviously lower latency is extremely important for an operational forecaster. However, maybe there are situations where it could be useful even with the latency. Hopefully you know where to find that product in AWIPS. But also, actually, I just chatted with Carl Jones yesterday, and I didn't know this, but the Alaska sector imagery in AWIPS that I think most offices have access to actually does often clip the CONUS, the northern tier states, or northern 1 or 2 tier of states, every day, and again every night. You actually get access to additional VIIRS imagery, the 375 meter BIS shortwave IR, so your hotspot band, and your IR window imagery, which something I didn't know, but you could check your AWIPS today and load the Alaska sector polar imagery, and you'll see that you can load some high resolution imagery in that case. The goal, however, is eventually, if there's enough interest from the field, and we do see that there's value in this imagery over CONUS, is to get, and pie in the sky would be to get the direct readout imagery and make that available at the lower latency, 15 to 30 minutes, for bands that we know can provide you with value, provide that in AWIPS. However, in the meantime, we do provide that lower latency imagery on the CIRA Polar Slider webpage, so it's the same page as Slider, but you change your satellite selection to JPSS and the sector as CONUS, and you could actually have access to all single bands from VIIRS, as well as many RGBs and advanced products, again at the lower latency. And actually in this sector you can compare it straight up with ABI. So you have to go outside of the AWIPS to get the imagery, but this is a great source of swath by swath, VIIRS, every VIIRS swath from all 3 satellites. You could zoom in on the imagery, you could look at old imagery, overlay boundaries, draw on it, etc. So a great resource for viewing VIIRS. I think probably the best resource currently outside of AWIPS. Again, all individual VIIRS bands available and ABI bands, in addition to some multispectral advanced products and VIIRS RGBs. Most RGBs that you'd ever want to load are there, as well as the ABI RGBs. So you can actually overlay VIIRS on ABI and compare the two. Again, this is the low latency VIIRS imagery from the direct readout. Also, you have some of the advective layer PW and blended TPW products on that page as well. So this is what it looks like. You can see swath by swath images from day to night available in that CONUS sector. Similarly, you could load the ABI imagery, and then you could load both together if you wanted to. And I think something I just wanted to bring up that doesn't really have much to do with this presentation, but a lot of people aren't aware that on the left side of Slider, on the bottom, there's a mouse draw option, and you could actually annotate the imagery by drawing, making arrows, and adding text, which could be a great tool, especially maybe if you're on site for a DSS event or whatnot. You could use Slider and annotate some imagery for providing DSS, social media posts, etc. So starting out with kind of the meat of this presentation, where does Bill think VIIRS could provide complementary value to GOES? Well, first, hotspot monitoring. If you're monitoring wildfire hotspots, obviously you're using GOES imagery. Hopefully you have 1 minute imagery. You're monitoring the imagery minute by minute. For those really small fires, fire starts, cooler fires, they're taking up, maybe just a few acres. They're cool still. They're not really showing up as well in GOES yet. This animation is switching between a GOES and a VIIRS image valid at the same time, and you could see some of these smaller hotspots in VIIRS aren't yet apparent in the larger GOES pixels. Some are actually two hotspots really close to each other. They look like a single hotspot in VIIRS. This example is in Idaho. And at the very least, a hotspot might appear in both images, but you get a more precise geolocation from the VIIRS imagery. The VIIRS imagery is also terrain corrected, so where those pixels are where they are in real life. They're lat long. So I think having the higher resolution, 375 meter for the hotspot band compared to 2 kilometer for GOES, soon to be 1 kilometer with GXI. I think there's complementary value there, especially if you're using direct readout. You're getting the image maybe up to a half an hour after the GOES, but if it's a really small fire that's maybe smoldering, sometimes you could have a small fire smoldering for days, maybe in a remote area, no one's seeing it, no one's reporting the smoke. You might see a signal in VIIRS. So you might, every afternoon or so, if you have high fire danger, check the VIIRS imagery. 3.7 micrometer band, I4, to see if you see any hotspots that aren't obvious in GOES. Here's an example on Slider of how you can actually use the slider function on Slider and switch between the GOES ABI on the left compared to the VIIRS on the right. This is for the recent Southern California wildfires. You can see even when there's fires there, obviously, and these fires are in populated areas, but thinking maybe remote areas, you get better definition of the fire boundaries, maybe which parts around the fire are burning faster. You can see that which areas maybe aren't burning, whereas the GOES pixels fill up a much larger area. This is an example comparing GOES and VIIRS with the DayFire RGB. Again, this DayFire RGB, which gives you an idea of both the hotspots, burn scars, and smoke plumes, available also at 375 meters. Again, you're seeing where the hotspots are from GOES, but maybe you get a little better definition of exactly where the fire's hot and burning along the edge, especially for like a grassland fire like this one, where it might be a very small area, a lot less apparent in GOES. And even to the southwest where you had these new fire starts, you can't quite see them in GOES yet, especially through the high cloud cover, but you start to see some new pixels develop in the VIIRS imagery. Then here's a short animation. Looks like, I think, 3 or 4 images, 3 image sequence from this event. You can see the new fire starts to the southwest that I mentioned earlier. So you do get these short animations, again, 3 to 6 images per day, and again at night, to see maybe a short-term trend in a feature such as fire evolution. Here's an example, not in the CONUS, but close enough. Nova Scotia, a fire from June of 2023. It was pretty neat. This is looking at the fire temperature RGB, which would be 750 meters from VIIRS. Again, you get an idea of exactly where along the boundary the fire is still active in the VIIRS imagery. So the other application, I think fires is a big one, and the other where I think VIIRS might be helpful for CONUS offices is for nighttime low clouds, especially currently, since with GOES you have like the nighttime microphysics RGB at 2 kilometer resolution. For VIIRS, that would be 750. I think this would especially be helpful for very localized areas of fog, maybe fog that's just developing, but also fog developing in like river valleys or high mountain valleys where very narrow regions. So this is an example from the GOES imagery. You see the low clouds and fog developing, kind of squirming through this river valley. You see some other areas that are suspect, but maybe not as clear. With VIIRS, a little over double the resolution at nadir, so even better further from nadir. You see some of these more smaller areas within the river valleys here in the southeast US that maybe aren't as clear from GOES. So from GOES, you're seeing the temporal evolution really well, and maybe VIIRS is giving you a peek at some of the localized fog that isn't as obvious in GOES. So using them together, I think, could be valuable. And here's a one-to-one comparison between the two. Again, you could do this in Slider to compare what you're seeing from both instruments. So these areas to the southwest, especially, there's some fog that wasn't obvious to me in the GOES imagery. And this might, especially if you have a TAF site, maybe fog developing near it, especially very localized, that isn't as obvious in ABI at first. Here's another example where it's actually animating through with the GOES imagery, but just stitching in the VIIRS imagery when available. I think this is kind of a neat use of VIIRS, kind of embedding it within GOES when it's available for that image, so that it kind of gives your mind an idea of what the rest of the GOES images might look like if they were higher resolution. When you're supplementing, some images with the high resolution VIIRS, your brain can kind of think that, okay, as I animate this out, I know these colors that were a little suspect to me are actually low clouds, as confirmed from the higher resolution VIIRS. Some of these next couple slides are becoming a little more niche, especially for Northern Plains offices. There's blowing snow, and we've been working on this blowing snow RGB. That's really capturing some of the HCRs, horizontal convective rolls, that we found to be associated with blowing snow at the surface. So like these narrow northwest to southeast oriented plumes. Sometimes they're very localized, very narrow, and less obvious in the ABI. Those really smaller scale plumes, which would have basically 1/2 to 2 kilometer resolution with the bands, versus from VIIRS 375 meter. And you could see just north of the Canadian border, some of these narrow plumes do stand out a little better in the VIIRS versus GOES. So again, if these are features that are evolving at more rapid time scales, but maybe if it's an event where the plumes remain very localized, that latency in the VIIRS, you might be able to overcome it by being able to see those very, very small scale features. And here's just one more example over southeast South Dakota, looking at some kind of northwest to southeast oriented plumes of blowing snow. Dust is another one that's, maybe there's some value there. This one on the left is comparing ABI and VIIRS for actually a very recent dust case, where looking at the day land cloud RGB, which you can get at, again, 375 meter from VIIRS, some of those plumes really do stand out a little better, especially exactly where their sources, where that dust is originating from, and you could actually better see kind of the individual plumes, which kind of become more blurred together in the ABI imagery. So maybe for a dust event that's just beginning, or it's very localized, small scale, or for whatever reason you want to know the exact point that dust is coming from, VIIRS could be helpful when used with GOES. And then here's the short, I think, 3-image animation looking at that dust event. Hail swath detection. This is more so kind of, I think, viewing angle and getting lucky. So this was an event near Pueblo, looking at GOES East first. if you're interested in, knowing where accumulating hail is occurring, I've talked about this before. A day cloud phase distinction RGB will show you accumulating hail as a swath of green, similar to snow, what snow cover would look like. From goes east, you don't see anything, and from goes west, you actually do eventually see a hail swath right there, but not until later in the animation. I think it was closer to 22Z. But actually looking at a VIIRS pass that was at about 2030 UTC, because it was overhead, I found that from goes east, this anvil was blocking the hail swath, and from goes west, there were anvils from other storms blocking the swath. So the overhead view, in this case, more getting lucky, but another view, another viewpoint, you're not looking at a steep angle from the east or west over the central plains as you do from east, goes east and goes west. That overhead view might give you a unique perspective to see surface features that you wouldn't otherwise see. So in this case, hail swath detection, but maybe in other cases, seeing fire hotspots that might be masked by clouds and other imagery or other surface features. This is to me maybe more of a prettier picture than anything, but being able to see the storm top detail in IR imagery at 375 meter compared to 2 kilometer just looks really cool, but it might be useful to be able to see maybe smaller scale overshooting tops that you couldn't otherwise see, or maybe developing convection. Again, maybe this would be most useful at night when you don't have visible imagery to see some of the detail in the storm top. Maybe gravity waves that might cause turbulence that you can't see in the coarser ABI. And then speaking of spectral advantages or unique spectral characteristics, the VIIRS Snowmelt RGB is unique because it has this 1.2 micrometer band that GOES doesn't have. And combining these bands allows you to basically assess differences in snow grain size due to differences in whether it's fresh snow, smaller snow grains versus dirty or old snow, which has a larger grain size, or ice. So basically down to it, the lighter blues would be fresher snow, the darker blues would be older snow or even ice cover. And this would allow you to gauge a number of things. Where is my snow ice line? Clearly see it in this case across southeast North Dakota, where ice fell to the north, snow to the south. That might be useful in verifying your forecast or maybe for other purposes, but also assessing the blowability of the snowpack. A fresher snow, the lighter blues are going to have more potential to develop into blowing snow compared to the dark areas. And this was just one example where the the Grand Forks, North Dakota office used the Snowmelt RGB in their forecast and basically determined that the snow would be blowable for the next few days from that imagery. And again, this would be available on the Sierra Slider webpage. Nighttime smoke detection. So I think now I'm getting into the rest of this talk, looking at applications of the day-night band that might be unique. Of course, day-night band is not available from GOES, and what it's doing is measuring reflected moonlight off of surfaces. So one great advantage is, I think, for smoke detection. Smoke detection is extremely difficult at night because it typically doesn't show up in the IR unless it's really ash laden, close to a fire. But if you have smoke traveling hundreds of miles from the source and getting trapped in the boundary layer at night, causing visibility restrictions, you don't really see it in the IR. But in the day-night band, it does show up quite well. This is just a still image. It shows up better if you animate the imagery, but in this case, actually, from a few years ago, I think Bismarck office was using it to assess smoke cover in their area that was actually reducing visibilities. I think smoke is a big one for a day-night band over the CONUS. This is an example from the Northwest. You see this wildfire. You can see the glow of the fire from the day-night band, and you can see the evolution of smoke. Maybe you're forecasting for around Portland. You're seeing visibilities become restricted. In the IR, you're probably not going to see anything, but with the day-night band, you can see that smoke is moving over, and you've got quite a bit of smoke that's going to be coming towards that area. And maybe using this in conjunction with, at night, the HERS smoke model to assess how HERS smoke is doing. But at least with this, you're getting an observation of the smoke. So smoke, definitely, I think, big advantage for using the day-night band at night. Wildfire, I mean, you're going to use, I think, still GOES imagery and from VIIRS 375-meter imagery to see the hot spots. But actually at night, you could use the day-night band to not only see the hot spots, but also the burned area. At this wavelength, you can see the darker pixels are where the fire's already burned, something that probably isn't as clear in other infrared imagery. And also, I think we found that some cases, very small fires, we found a glow in the day-night band that wasn't apparent in shortwave IR imagery. Fog, it's another one that, you know, maybe there's some value at night for fog. I already talked about using the higher resolution 750-meter nighttime microphysics from VIIRS. You could also take a peek at the day-night band for a visible-like image, if maybe the color's not so clear in the RGB, looking at the visible imagery at night. In this case, actually, this is when I was still working in Pueblo. I thought it was pretty useful to see those, where these patches of low clouds were actually located from the nighttime visible imagery. So I think for a day-night band, smoke is a big one, and low clouds, maybe there's some value there. This was an interesting case I was thinking of the other day. For if you have a snow event where, you know, snow fell during the day and maybe into the evening, and you had cloud cover during the day, but overnight, maybe early in the evening, the clouds have eroded. You could actually get a first look at the snow cover. You probably wouldn't be able to see this in the IR, maybe, but from this nighttime visible imagery, you could clearly see where the snow streaks are through Oklahoma City and the rest of Oklahoma as those clouds move out. I think that could be useful in knowing exactly where you had the snowfall early on, instead of waiting for the next day. This was a case recently of looking at those blowing snow-induced horizontal convective rolls. Again, at night, these are narrow plumes. The IR 2-kilometer resolution imagery maybe doesn't capture them so well. They're close to the surface, so the difference in brightness temperature might not be there. So maybe the day-night band could help. And in this case, I think the forecast office was actually viewing the day-night band to see those rolls, and within them, you had significantly reduced visibilities. So again, taking advantage of visible imagery at night. This was one of the recent lake effect snow events. This was from last week over the eastern Great Lakes. I don't know if there's value in, I'm not a Great Lakes person, seeing sea ice where the sea ice is. You could kind of see it in IR, but again, visible imagery at night, I think shows the sea ice really well, but also where those details about where the lake effect snow bands are setting up. In this case, the band, I think, produced pretty heavy snowfall near Syracuse. So basically, any situation where you think visible imagery would be helpful, maybe take a peek at the day-night band. I like this case looking at thunderstorms. This was from last spring. Thunderstorms moving across Kansas, Missouri, Oklahoma, Arkansas. Highlighting a bunch of these features you could see that are really clear in this visible imagery at night that the IR doesn't quite capture as well. You've got boundaries, being able to see where those boundaries are, along which new convection's developing. You could see these towering Q, you could see the shadows that, of course, you wouldn't be able to see in IR imagery. Lightning flashes, that's more of, I think, a neat thing than maybe useful operationally. Overshooting tops, very clear in the imagery, but also above anvil cirrus plumes, indicating the strongest thunderstorms. Very clear in this imagery that those are really hard to diagnose at night, I think, in the IR alone. So I think for thunderstorm events, if you're trying to assess boundary locations, especially, I think maybe the day-night band could be some help. And then I think I have this in here more just because it's cool than anything. Adalia, as it approached landfall in August 2023, had some nice day-night band imagery, but I think forecasters have used this imagery for, especially for more disorganized storms, being able to get a center of circulation from the day-night imagery, but also assessing the locations of low clouds in tropical systems that aren't as clear in the IR imagery. And maybe if your eye is becoming clouded over at night in the IR, you might not be able to see a distinct eye, but in the VIS, you could still get some picture of it. So that was the last example. This one is looking at wildfires over Australia over, I think, the course of a month in 2023. I just thought it was a pretty cool example from the day-night band. So interested to hear your ideas or concerns about using VIIRS data or questions. And of course, I'm always open to taking emails about any of this. Thanks a lot.
All right, thank you, Bill, for that great presentation. And before we go to the Q&A, we're gonna have a few announcements. I just want to highlight first that we encourage attendees to please stay on for the discussion. And we also encourage everyone to change their meeting layout within the Google Meet interface to tiled and select hide tiles without video. In addition to that, we also recommend attendees, if you have a question, to please submit within the chat interface there, or indicate verbally if you want in the chat room if you have a question. Additional announcements here, in a week from today, on Thursday, February 27th at 12 p.m. Eastern, Dr. Isaac Murati will be presenting on remote sensing research scientist. He's a remote sensing research scientist from NASA and UMD ESSIC, and he will discuss satellite observations for tropical cyclone predictions. Now, we also encourage attendees to contact the TowerS team, Kashad Bowman and Emily Maddox, for questions about the SBC or for configuration of satellite products. And now from here, we will start with some of the Q&A there, Bill. I do have a question or two here first before we go into the chat interface. My first question for you is, with utilization of the day-night band, the nighttime visible imagery, have you observed any hail swath cases at night from the day-night band?
That's a good question. Yes, I have. And I thought about putting in this presentation, but I didn't. But yeah, could certainly see hail swaths at night. I think that's a good application of day-night band, especially during a full moon with that better illumination. Narrow swaths, sometimes you could see them in IR imagery at night if it's, it's going to be colder, of course. But I think the day-night band could provide a good view as well. And yeah, definitely I've seen cases.
Yeah, because I know you have to consider the hail depth and the hail spatial extent in addition to the timing and other variables, as you mentioned. So there was that question there. And then also just for users, generally speaking, with respect to the VIIRS data, is that terrain corrected in AWIPS and on Slider?
Yes. Yep. The VIIRS imagery is all terrain corrected.
All right. And now we'll transition to some of the comments and questions in the chat. First one here from Sheldon Cusselson. With respect to when you were talking about the latency and the direct broadcast capabilities, he mentions that with direct broadcast with the NESDIS snowfall rate product can be approximately around 20 to 40 minutes with this LEO satellite product. And he mentions a few links there via, I think, NESDIS Star and also from Sports. In addition to that, another comment is from Joe Fiore. He mentions great presentation. He mentions that himself at NESDIS User Services has been trying to get more users to be aware and use VIIRS imagery with GOES imagery. And of course, Alaska really uses the VIIRS and other polar imagery and products more, of course. And he mentions, good to know that Northern US and others, as you said, Bill, and showed so well, can benefit too. Joe has worked and talked with myself and others about this topic for a while as well. And he mentions, thanks for the presentation. Bill Schoberg mentions as well, he says he likes your emphasis on VIIRS use to spot early fire developments or to track changes in existing fires. And also says VIIRS really showed its value during the Canadian fires, where the U.S. Central and East Coast was heavily impacted by smoke. Sheldon also replies or has a comment of the new features that you see with the VIIRS high resolution imagery can be helpful in learning more about different aspects of severe weather in the cloud, and that you would never know about if you were looking at the lower resolution or coarser resolution ghost that also may be obscured by some clouds. And I think Lee had a response back to Sheldon there for some of those links. It has some additional follow-on of for NWS AWIPS. The SFR data is available in AWIPS provided via regional LDM, and mentions the AWIPS menu path there. And if there's any additional questions, let him know. Looks like there's a question from Dan Lindsay. It says, I really like that smoke at night example over Oregon. Do you have a feel for smoke's detectability in low or new moon conditions?
Yeah, that's a good question, Dan. Yeah, and I should mention that the new moon is going to provide you obviously with the most moonlight and the better reflectance, or more light to reflect off of surfaces such as smoke, snow cover, clouds, etc. So you're going to get your best nighttime visible image or day-night band image near the full moon when you're in a new moon. So you don't have as much moonlight, you don't have as much light to reflect off the surfaces. Those features become dimmer. The city lights kind of dominate the scene more so during the new moon phase. So yes, features like smoke become much more difficult to detect in the couple weeks surrounding the new moon. I did want to mention, sometimes the default color map and scale especially for day-night band is not ideal. So I'd actually recommend, especially around the new moon, using the GOES visible square root enhancement for the day-night band, and maybe adjusting the max value for the day-night band. Maybe I think default is like 1.6, maybe put it to 10 or 20. So that kind of dims down the city lights and other features like maybe clouds or smoke. You might be able to get a little more play out of them if you mess around with the color map and the range. But yeah, something subtle like smoke is going to be very difficult to see within the couple weeks around the new moon, Dan. And I really want, if there's any forecasters, weather service folks on the line, to pipe in if you have any thoughts on any of this, the viability of some of this in operations. It would be great to hear from you.
All right. And then I do see that Bill Schoberg mentions, and just as a follow-on, I know this is a VIIRS-centric presentation, but from the JPS's point of view, we also have satellite soundings from UCAPS that can be utilized for a lot of these different applications, such as like fire monitoring, etc. And that's available in AWIPS. Now I'll refer to Michael Jamokowski. I believe he has a verbal question. And go ahead, Michael, when you're ready.
Yeah, can you hear me okay?
Yes.
Okay. Hey, Bill, how you doing? This is Jammer in Silver Spring.
Hey, Jammer.
And another great presentation, Bill. I always learn a lot from you. I'm an old dog, but I can learn new tricks, And I'd like to talk about latency, VIIRS latency. I worked the NPOS program back in the early 2000s, and one of the primary items that won the contract for Northrop Grumman and Raytheon for the ground system was 30-minute latency of the data. And the idea was to do that by a system called Safety Net, where we're going to put 16 ground antennas around the world in 10 countries so that we could achieve that. Now, I don't know if it's changed much in the last 10 years, but I remember that the VIIRS processing chain is pretty complex in there, and that was one of the things to get over. Now, but referring to your presentation, you said that the remote users can get 15 to 30 minutes latency on their data. Are those data just used locally, or is any of that fed into CONUS Weather Centrals?
Yeah, no, the CONUS offices are not getting any direct readout imagery. And as Michael Bolin, he stated about latency, that's the biggest roadblock about getting forecasters in CONUS offices to use VIIRS data, VIIRS imagery. In Alaska, they have their direct readout data. They're using it. It's very useful to them. But in the CONUS, they get this highly latent day-night band imagery, and that's it. And that's not as useful, again, if it's an hour-and-a-half minute late. But if it's more like 15 to 30 minutes from direct readout, that would be useful. So I think the key to getting forecasters in the CONUS to use VIIRS imagery and other VIIRS data is to give them access to the low latency direct readout data. We're doing that with Sierra Slider, but really we need to get it in AWIPS if we want them to take full advantage of it. Thanks, Jammer.
Yeah, thank you. That makes a lot of sense. Thank you, Bill.
All right. In addition, another verbal question, this one from Lihang Zhao. Lihang, whenever you're ready.
Hi, Bill. Excellent presentation. I do have a quick question about the data format. So right now, our VIIRS imagery EDR are in HDF5. From your experience and the inputs from our users, do you think that's a good format going forward for the new missions for LEO? And also, right now we have all the channels as each channel as EDR, but since the RGB seems very powerful and widely used by the users, maybe some of this can be also considered as future imagery operational product, of course, based on the user's inputs. Thank you.
Yeah, Lihang, good questions. With file format, I mean, the current format has worked fine for me. I think getting it into AWIPS, but I'm not a file format expert, and there might be other people that have better ideas that we'd be happy to learn about. And as far as products, the thing with RGBs is, our softwares like AWIPS can process those on the fly. So all we need are the individual bands, and AWIPS does the work to display the RGB. So really, to get something into AWIPS, we'd only need a few bands, maybe the fire hotspot band, and then maybe a few bands to create the nighttime cloud imagery. You don't need to send the RGBs separately. AWIPS does that. So kind of that's the beauty of it. And I think VIIRS imagery, compared to everything else, doesn't have that large of a data footprint. So I think it's something that should be viable. But thanks, Lihang.
Thank you.
All right, we'll go with another one or two more questions here. Next one here, Jonathan Case mentions, do you have any use cases for dust, fire, or smoke in other areas of the world that commonly experience these issues, such as Southern and Southeast Asia? Did you compare the VIIRS imagery to GK2A and or Himawari like you did with GOES?
Yeah, that's a good question. I'm usually focused on the CONUS or Alaska. I've done some fire imagery comparisons over Australia. You could check the blog. Maybe just search the blog for some of those examples. I haven't done much elsewhere though, but I'd say check the blog and check the SIMS blog and the Sierra satellite library. Just Google that. They have a bunch of global examples, and you might find something, but not too many that I can think of off the top of my head. Thanks, John. And
then also, Bill, did you address Michael Boland's question already?
Yeah, I think we got that with the latency.
All right, and then I know if I scroll down a little bit, Jack Settlemeyer mentioned about a working link to Slider. I already provided that to him. And then I think he mentions that with respect to Slider, every time he tries to change another channel like that one, nothing would show for him. And I know, like, sometimes you got to refresh the browser, sometimes reload some of the channels for it to display. And I think Dan Lindsay's addressing that.
Yeah, thanks, Dan. Yeah, I think that should be stressed. Every time you zoom in to a different area, when you're done zooming and you get to the domain you like on Slider, refresh it. It makes a huge difference. The boundaries look better, and it works a lot better. So just remember, every time you're done zooming, refresh.
Sounds good. Well, it looks like I don't see any more questions, so we'll come to a close. And thanks again, Bill, for that great presentation. And then I'll pass this back to Dan Lindsay for final remarks.
Thanks, everyone.
Go ahead, Dan.
All right. Yeah, thanks a lot, Bill. I always learn something new with your presentations, and this one was no different. So thank you also to Jarrell for your excellent facilitation. As was previously mentioned by Jarrell, a week from today, Dr. Isaac Murati from a remote sensing scientist from NASA and UMD ESSEC is going to discuss satellite observations for tropical cyclone predictions. So we'll see you all here then. And thanks a lot. Have a good day, everybody.